Hi guys, greetings from Bulgaria, I am Anton, and in this video we are going to cover the builder design pattern, part of our course about design patterns in automated testing. What we covered so far. First, we discussed the proxy and adapter design patterns, where we improved significantly the iWeb driver and the iWeb element interfaces. We added new methods and made our tests more readable and more maintainable. In the second module out of this course, we covered the decorator design pattern, where we use it to add flexibility and extensibility to our mini test framework. Then we covered the singleton. Singletons are quite useful, making our code more usable, improving the API usability. It can be used together with other patterns such as factories, repositories, builders, page object models, and others. Then we covered the dependency injection, which is quite useful in building sophisticated test automation frameworks. We covered the chain of responsibility, and we use it to bring troubleshooting features to our mini test library. Also, we applied the strategy design pattern for adding flexibility to our mini test framework, for adding new wait and find strategies. Last but not least, very fundamental video about test data management, where we covered repository and factory. Please check it. Because we are going to upgrade this particular solution in the current topic about the builder design pattern, but I will give you a quick refresh on the topic, even if you haven't watched the previous module. And in the data-driven testing pattern module, we covered these modern unit testing frameworks that give you the flexibility for using data-driven approach, for not copy-pasting all of the tests, but we can reuse them using attributes, annotations. We can provide test data via Excel sheets, etc. It's quite useful. So, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when each week a new video is published on the Lambda Test YouTube channel. Also check the Lambda Test blog, where modern best practices about test automation are discussed in many details. In the links below, you are going to find the source code for all of the demos that I'm going to present. I suggest to clone the repo, and play along with the video. Also, you will find there the demo application that I'm going to use in our examples. I'm going to explain it shortly. Also, you will find related resources and jump links to the different parts of the video. And of course, you can modify the speed. If it's too slow for you, you can speed up or lower the tempo. So let's get started. In this particular module, we are going to cover the builder, but as I said, first we're going to see the previous solution that we use for test data management, because now we are going to upgrade it using the builder. So I'm going to present the demo app and really quickly give you an overview again about the repository and factory. If you already watched the video about that, you can jump directly to the action where we implement the builder. Then we are going to discuss, of course, the simple version of the builder, and then we are going to use it in our tests in a much more real-world example. So let's get started. First, my demo application is built on top of this tutorial about SQLite tutorial, where this website provided this database about a music shop. And this music shop is a database where we have customers, we have responsible employee for each customer. Each customer can buy tracks or albums that are recorded by an artist, and those tracks are grouped into playlists and from different genres. So I created the following front end for that. It's very simple. Basically, I exposed through the UI all of the operations that we can do against this database. We can search for an artist, we can update the artist, we can delete it, we can show all of its albums, and we can view all the tracks part of one of the albums and the different prices and sizes. Also, we can add an artist, we can check all the customers. This is more sophisticated, as you can see. We have in the previous module about the factories and the repositories, we tested and created tests for this more sophisticated filter here with and or nor, because there are some bugs, of course. Also, you can add a customer here. There are some front-end validations. And as you can see here, we have all the CRUD operations, but also we can see all of the invoices for the customer, all of the invoice items related to the particular invoice, view all of the responsible employees, and that's it. You can, as I said, clone this particular application. From this, you will find the link in the description below, this Music Shop frontend, simple name. This is Node.js application, so when you clone the repo, the only thing that you need to do, navigate to the folder of the repo and call node server.js, and then everything starts. Of course, you need to install Node.js, that's the only requirement. And really quickly, if I need to explain the demo project itself, I try to make it as simple as possible. There are only two important files, index.html, of course, as you can guess, here is the whole front end. I used here Bootstrap, inline CSS instead of have a separate CSS file. And also at the bottom, we have a lot of JavaScript in a script tag where we call the backend, the web API, to fetch the data and update the front end. And of course, the backend is placed in this server.js where we have Node.js code for declaring the different API endpoints. Yeah, I use JavaScript to write queries against the database and return them in a JSON format. So besides the front end, as I said, for example, here we have an API customer that returns all of the customers, right? Or I can get in the form of a JSON. And then if I type here the ID of a particular customer, we can return just one of them. And I did that for all the tables. And also we have additional endpoints for writing the search queries, etc. So we are going to use these endpoints in our tests to create the test data for the front end, or if you need to write additional tests for the API tests. Now, in my tests, I use a library called 𝑨𝒏𝒕𝒐𝒏. In a minute, I'm going to show you how I installed it and set it up. This is their website. This is the most popular library for making web requests in C#, and we use it for testing as well. The usage is straightforward. We just install this NuGet package dependency called 𝑨𝒏𝒕𝒐𝒏. After that, we add the two usings here, and the main thing that you need to use is this object called REST client. If we have additional options, we place them here, initializing this REST client options object and provide it to the constructor. And after that, it's very straightforward how we use it. We construct a REST request object and we provide it to the different methods like get, put, post, delete, etc. Most of the time this is used as asynchronous code. This is why you need to use the await keyword. But if you wish, there are other overloads for the methods that are not asynchronous. Or you can place .result or get a waiter, and this will work. The other main thing about the 𝑨𝒏𝒕𝒐𝒏 is that instead of dealing with directly with these JSON objects and parsing them, etc., nobody does that now. Instead, this JSON is serialized and deserialized to C# classes. We call these classes models. In a minute I'm going to show them to you, but we work directly with properties and methods instead of working with text and JSON. You can check the ResSharp or the previous video where I discussed in more details. Now, this is our sample project. In our sample project, first let me show you what is the setup. I installed a few NuGet packages. We have all of the standard NUnit dependencies here. If you're not familiar with NUnit, check the links below. You will find a whole course on the Learn the Test YouTube channel about NUnit. Maybe the most popular unit testing framework in C#. As I said, I installed ResSharp, and from the front end you can use no matter WebDriver, Playwright, it doesn't matter. I use here WebDriver since it's the most popular, and I installed also a few other NuGet packages needed for the Selenium for backward compatibility, for example the WebDriver Manager. But if you use version 4.11 and above, you know, the management for the drivers and the browsers is now coming out of the box, instead of you don't need these dependencies anymore. And also we need one more library that I'm going to explain in a minute. It's called Bogos. We use it to create fake data in our factories. That's basically it. And as I said, for example, for the customers that I showed you, we have those model classes. This is why they are placed inside a folder called models. For each of those endpoints, like customers, albums, etc., we have such simple classes where each node here, like city, is represented by one string property, integer property, or boolean property, right? Very simple. And actually Visual Studio can generate that for you if you don't have them. There are other tools as well, but if you go here and go to edit, paste special, paste JSON as classes, basically Visual Studio will generate this model class automatically for you. Maybe you will need to modify it a little bit. For example, for nose, it doesn't know what is the type, so you will have to manually update it to string, and maybe you know, change the name afterwards. But it's very straightforward. There are other online websites for doing the same, but I don't suggest using them, especially for production code, since you don't know, you know, who owns the servers and the websites and where your data will go. So I always check if I install extensions whether they do web calls or not before using them. But I suggest to use directly this built-in capability in Visual Studio. If you are working with Java, there is a similar functionality in IntelliJ. So yeah, I generated all of those model classes for us, and then we have different repositories. What is the repository? The repository, as you can see here, it gives us flexibility to do all of those CRUD operations, like let them collapse all of them. As you can see, we have get by ID, get all. We can create an object, we can update it, we can delete it. So in short, the repository design pattern is widely used design pattern that abstracts the way objects are stored, retrieved, and manipulated from the database in an application. It acts as a middle layer between the business logic and the data mapping layer, effectively hiding the details of data access, you know, the data access mechanisms. The pattern is particularly useful in applications with complex domain models, and it enables developers to work with more object-oriented view of the data like these models. And calling your wrapper an HTTP repository can be appropriate if your wrapper is designed to abstract the complexities of this HTTP communication while presenting a simple interface for performing CRUD operations like I'm doing right now on the entities, and as if they were being directly managed in a local store, right? This naming aligns well with the repository pattern's goals. This is why I use this particular word. However, on the other hand, naming it a client, this is again widely used. is also suitable, especially if the wrapper's functionality encompasses more than just CRUD operations, including actions that are specifically to consumptions of a particular RESTful service. The term client broadly indicates that an entity that consumes service provided by another system or a component, which in this scenario is a RESTful API. Here, as I said, in the base class for all of the HTTP repositories or clients, it doesn't matter what word you are going to use, we have this generic class where T entity will be replaced with the actual type of the model. For example, for the customer, we specify here customer. For album, we'll specify here album. And yeah, this is a generic parameter. And inside of each of these CRUD operations, we're just constructing the REST request method that I explained, and we are executing the request. After that, if you want to deserialize your JSON response and get the actual model class, we call the data property. I did the same for get all. Here the only thing is that now the data is presented in the list of T entities, right? For the create, one specific thing is that we need to add this T entity as a body, and the library will automatically deserialize the entity to a JSON and then supply it to the HTTP request. So we have repositories for all of our major endpoints, for artists, for albums. Sometimes, like for the customer, I have a custom endpoint method for the search. This is why I added this new method to the child class that implements the HTTP repository. That's that. And then we have the factories. What are the factories? A factory, for example, for the customer or for the album. A factory is an object for creating other objects, right? At the end of the module, I'm going to explain the difference between this approach with factories and repositories and then with the builder. But for now, let's keep it simple. So a factory is an object for creating other objects. In simple factory pattern like this one, we have factory class, which has a method that returns different types of objects based on a given input. In this case, we return album. The simple factory isn't formally a design pattern by the classic definition as per Ganka 4 design patterns. Instead, it's more of a programming idiom or a design technique. A simple factory encapsulates the object's creation process into a single method, often in a single class. This method decides which class to instantiate and returns an instance of that class. This album factory simplifies the creation of albums, and it ensures consistency, reusability across the application. Also, here we utilize everywhere this bogus library or a faker library to automatically populate these instances with fake data for properties such as album ID, title ID, artist ID. This approach is particularly useful in testing environments where generating realistic data quickly and efficiently is crucial for validating behavior without the need for real database records, right? So here is, for example, the customer. We can generate that, as I said, instead of using bogus, we can use random IDs or first names. But again, bogus will generate a fake real data, real names, real emails, real phones, etc. instead of using this approach. This is why I suggest to use Faker. It uses similar fluent API or chaining methods that we are going to use in the builders. So yeah. And if we want to use them in tests, I already did that. So here I wanted to create tests for the web API. This is why I, in a class with tests, we annotate the class with this test fixture attribute. The setup is called before each test. So here we use the factory to generate the entity, right now, until here, it doesn't go to the wire. We are not creating anything. In order to create it, delete it, or do something with it, we need to use the repository. This is called separation of concerns. We basically have two different classes dealing with different tasks. One of them is to create the data itself, and the other is how to communicate with the endpoints using the REST sharp. So here with the customer factory, we created this default fake customer, and then we created it. After that, we assured that it was created successfully, or maybe you can do here get request, and then we delete it at the end. Here we tested the get by ID, as I said, and here we tested the search, where I created two customers, called the search, and then afterwards in the cleanup phase I deleted the customers, etc, etc. Now, if we want to test the front end, of course, the whole point here of having those patterns is that if we need to test the front end using WebDriver or similar library, we want this test data management. We need to prepare the test environment. Many often we have different instances of our web applications on different environments. Thus, we need to prepare the data. And this is exactly what I did here in these music shop tests. I initialized in the setup all the repositories, most of them, and then I wanted to prepare an artist with all of the customers, all of the tracks, all of the albums, all of the invoices and invoice items to it before all of the tests. And now, what we did here. First, we created a default artist using the factory, right? We changed the name. We created the artists using a post request using the repository. Then we assumed that we want to create two albums. We generated the albums with generated two default albums using the factory for albums. We changed the titles to be unique. We created them with the repository. After that, we assumed that we want 5 tracks. But as you can guess, this is not very flexible, because every time I will need to modify the numbers, I will need to modify the names, etc. This is not very good solution, but we are going to improve it using the builder. This is why I'm giving this example. So we wanted to have 5 tracks per album. This means that I use the factory for tracks, I change the name, I assign the proper album, then I create the track. Then inside the track, assume that 10 customers are going to buy this track. This means that I'm creating the customers, every time unique customer here, based on the IDs. I'm calling the customer repository now to create a post request for the customer. And then for each particular customer, for each purchase, we need to create an invoice with a particular unique date, and then to each invoice we need to assign the different invoice items per all of the tracks. As you can guess, this is very complex setup that we don't want to repeat every time. It's not flexible at all, and it's a very bad practice to put this directly to your tests, because probably you're going to end up with multiplying this, copy pasting it in many places, and this will be really hard to read and maintain over time. It doesn't matter what we do later here. We're going through the UI using the already generated data from above. But yeah, we're going to see another approach using the builders. Let's return to the presentation quickly, and let's discuss the builder design pattern. What is the builder? The builder design pattern is a creational pattern that is used to construct a complex object step by step. It separates the construction of a complex object, like we did right now with this complex music shop construction. And so yeah, it separates the construction of these complex objects from its representation, allowing the same construction process to create different representations. Like, for example, you can modify the number of albums, number of tracks, change the names, etc. This pattern is particularly useful when an object needs to be created with many possible configurations. Like as I said, we may want to create 20 albums, or I don't know, 30 tracks per album with totally different names, with totally different number of customers, and invoices. So yeah, in C#, the builder pattern typically involves the following components that you can see in the diagram here. We have the builder. This is an abstract interface that defines all of the steps needed to build a particular a part of this complex object. Then we have the concrete builders here at the bottom. They implement the builder interface and provide implementation for the steps defined by the builder. It keeps track of the representation it creates and provide methods for retrieving the final product. There can be several concrete builder classes, each constructing a different representation of a product. And then we have at the top the director, which is responsible for managing the correct sequence of object creation. It accepts a builder object and executes the necessary operations on it. And of course we have the product. This is the album, the customer, the invoice. This is the complex object that it's being built. And the concrete builder builds the product parts, and the product itself is returned by the concrete builder itself. Now let's see a very simple implementation of this pattern here. We have here this car class. We have maybe not make, but this is the name of the car. We have the model, number of doors, engine type, etc. So we have the car director. The car director class acts as the director in the diagram, and the car builder is a concrete builder that constructs the car product. The director can command the builder to produce different types of cars. In our case, this is a sports car and SUV. So, and the director, when it commands, it doesn't know the specific details of each car. This pattern provides flexibility in the properties of the object that can be created and simplifies the construction. And here is the interface that we can provide the names and the model, the numbers, the engine, cars, etc. And then we have the concrete builder, which is the car builder, which now makes this car, which is the name of the car. It sets the model, it sets the number of doors. Of course you can do it with properties instead of these methods, but I want it to be more understandable for people that are coming from the Java world. So we set the engine time, etc. And with the get car, we are returning the car itself that was built. And if we return here, as you can see, we are using this iCar builder where we use it. This is how you use it. You provide the actual builder here, and we say, please make a Ferrari, set a model, set a number of doors, the engine type, and then we return the car with this default data. This is a very simplified version of the pattern, right? Now, in our case, we are going to use, you can build simple builders, like here, I created a simple builder for my albums. I created here an empty album, and then we have these modification methods where we can set different album ID, different title, different artist. We can add tracks, and then when we call build, this will return the initialized object. Of course, this is a very simplified version of what we want. Before we go into the details, I want to show you now, in this builder folder, I created all of these interfaces for the builder. As you can see here, we have album builder, which contains all of the modifications that we can do to a particular album. We can say, usually this prefix with is very popular with this pattern, so I suggest to use it, with title. This means that we're going to override the default and have a different title or different tracks, and we can override that. As you can see here, for all of our builders, we have a base interface for that. What we have here in the base interface is that it accepts the artist builder, the concrete builder type, so that we can build this fluent interface or chaining methods. And we have the actual, like with the repositories, we need to provide the actual type, the actual model type. And what we have in the base interface is that we have a method with default configuration. In here, we are going to call our factories to create the default configuration for us. And then we can later use these additional modification methods if we want to have a different small modifications or huge modifications to the default. And when you call build, this will return our directly model, which means the album, the artist, the customer, etc. For all of them, again, I created for the different entities in columns, I created different with methods. Also, since I wanted to have different concrete builders, I created two types of them. One of them is transient and the other type is persistent. What this means? This means that sometimes we want to build such complex objects without persisting them, without saving them into our database, or without calling our repos and calling the web APIs. This is the transient object. Where we use the transient objects? Well, we have in our UI, sometimes you will want to populate here a customer, right? The correct customer with all the data. So we will want to use these transient objects to populate them in some front-end forms. And the persistent, as you can guess from the name, is the one that is very similar to the transient builder, but is going to persist them using the repo and factories together to save them. Now, as you can see, we have two types. Here, this will be a more complicated builder implementation using factories and repos inside. So you need to be very careful about the separation of concerns. Integrating external system calls directly within builder methods could lead to violation of separation of concern principle, mixing the logic for object creation with business logic or external services interactions. And to maintain this clean architecture, consider abstracting these external services integrations like we did with the factories and the repos into separate classes or services. The builder can then use these services like we're going to do, keeping its primary focus on object construction. So here is the test data director. Basically, I abstracted here the long chain of initializations that we had before in our test here. Basically, I copied the code from here, but I wanted to use now the builders, right? So here is what we do. In the test data director, we just provide the builder mode, which is persistent or transient. At the bottom, we have different private methods that return the proper builder, whether it's persistent or transient. The two concrete builders, we're getting the right one. If it's persistent, of course, all of these methods are going to return and create the new persistent builders of the same type. So we have implementation of the persistent builder for the invoice items and a transient version. And we have one main method called create artists with discography and sales. And we have some parameters here. We can modify the artist name, how many albums we want, how many tracks per album we want, and how many customers we want. And the thing that we do here is that we get the artist with the default configuration. In a minute I'm going to show you how this works, but basically inside we call our factories. So we create a default artist from the factory, and then we call this with methods to modify the default. As I said, we use the builder to create, we use it in this complex setup where we have many configurations, right? We cannot proceed just with the defaults. So we created an artist with modified name, we build it. Then we have again the for loop, but now instead of calling directly the factories in the repos, we just call the album builder. We modify the title and the artist, just these two modifications. Inside we have many more. We call build. So now we have an album, which if you pick the persistent mode, then this build method inside will call the repo, do the post requests, and create the repo inside the database. And we do the same for the tracks, for the customers, for the invoices, but again the director is the one who knows how to change them, how to call them properly, how to modify the data, etc. He's coordinating, orchestrating the whole process. We are not dealing with that. And now the separate builders, if we look into maybe a more simple version of it, for example, the transient album builder, it derives from this artist builder. We have an artist private variable here. We created an empty version of it. As I said, we needed to implement the main base iBuilder that defines this method with default configuration. Basically, every time here we call this artist factory generate artist. Since we are in the artist builder, in the customer builder, you're going to call the customer factory. So we are getting the default version of the artist, then we are returning this. This is how we implement this chain methods pattern Fluent interface. Then again, we do the same for the with artist ID. We are just initializing the artist, the name, the album, etc. And when we call build, we are just returning the private variable that we have here, right? Nothing more. But if you look, there is just a slight difference between the transient and the persistent mode of the builders. Of course, you can have a base class for that. Just for simplicity, I didn't want to make it much more sophisticated. So if we look into the persistent builder, the only difference is now that we use here the artist repository. We use it as a composition. We initialize the repo here. We initialize the artist. When you call with default configuration, now we have a default artist. And if we want to modify something, again, you will call some of the with methods here. But in the end, instead of directly returning the artist, first we are calling the artist repository create, which will make a post request to the API. It will return it, and then actually here, in order to have the proper ID, it should be like that. This will initialize the artist with the proper ID created by the endpoint. Then we are going to return it. But again, we have this Fluent interface, chaining the methods, right? And again, we have the same for the customer. For the persistent customer, as you can see here, we have a little bit more complex methods, like with this with address, with a bit more parameters, but the logic is the same. We just modify these modification methods. They just modify the internal customer object that we are going to retrieve, calling the build method at the end. But again, since this is the persistent customer builder, it will call the repo inside. Now, 3 points here. The first is that if you use the action API of Selenium, you will be very familiar with this Fluent interface. However, it's very similar because we use both the builder and the WebDriver actions class. They use the Fluent interface that allows for these chaining method calls. This makes the code more readable and easier to write. However, there are differences in the outcome. The builder pattern uses this build method typically, which returns a complex object, while the actions class calls this perform method, executes the queued actions without necessarily returning an object. So the builder is primarily about constructing objects, allowing for varying representation of object being built, while the actions class, on the other hand, orchestrates a series of user interactions with a web page. And the focus is on action sequences rather than the object state. There are some popular third-party libraries like 𝑨𝒏𝒕𝒐𝒏. You can install it via this NuGet package. It's very popular in Java. In C# this is its version. Here you can see how it works, but basically it gives you this 𝑨𝒏𝒕𝒐𝒏 represents an effort to bring some of these productivity benefits of the project 𝑨𝒏𝒏 from Java. However, as with any third-party libraries or tools, the basic thing is that here it gives you these with attributes that will automatically implement the builder for you, right? However, you need to be careful with any of these third-party libraries or tools. It's important to carefully evaluate all the features, documentation, community support, and how it fits in your specific development workflow and project requirements. Always consider the long-term maintenance implications of adding such library to your project, especially for critical or large-scale projects. And now to wrap up, I want to discuss the difference and to compare all of this code that we have now here with the builder and the test data director with the factories and the previous approach. The builder pattern, it allows for constructing an object step by step, explicitly setting each property. This approach is useful when you need precise control over the object's properties or when constructing objects involves complex logic. While the factory, or this, for example, album factory, is best suited for situations where you want just to quickly generate an object without with default or random values. It abstracts the creation logic and is simpler to use for straightforward object creation scenarios. The builder pattern can create different representations of an object by involving different methods in varying orders. We can modify the data. And this flexibility is beneficial when an object has many properties like our music shop, right? That can be optionally configured. The factory method is less flexible in this regard, and as it typically creates an object in one go with limited or no customizations options for the color. Of course, you can create multiple such methods inside the factory classes for the album factory, for example, but I always prefer to create such methods just when I'm going to use them multiple times in multiple places instead in just one test. So use the builder pattern when constructing a copyless object with many optional or required fields, especially if some of those fields are complex objects themselves, or if there are multiple representations of an object that might be required. And use the factory method for simpler scenarios, where you need to create instances of the class with standard configurations, particularly when these instances are meant for testing or when specific configurations are not crucial. So we covered a lot of topics. Thank you for watching. Check the Lambda test blog for many awesome articles. Put any questions below in the comments below. Check the Lambda test blog for many best practices. And of course, get your free certification about 𝑨𝒏𝒕𝒐𝒏, Selenium, JUnit, and many other technologies. Thank you for watching and see you in the next modules.